Hey guys, Mr. Mackey here. Now, yesterday I introduced you to a method of finding the spread of our data, which was known as the range, where we subtracted our lowest value from our highest value. And I set you this challenge to find a set of 6 numbers where the mean gets you 5, our range gets you 6, and our mode gets you 8. Now, the first thing we have to do to find this, let me just do these gaps here so we know we have 6 numbers to fill, is find out what they must all add up to ensure we get a mean of 5. Well, if we have a mean of 5 and there's 6 numbers, we have to multiply it so we know that all of these numbers have to add together to get 30. Because then you reverse it, 30 divided by 6 gets us 5, which is our mean. The second thing that we have to know is that our mode has to be 8, which means it doesn't matter how many times we include other numbers, but 8 has to appear the most times. Now, 8 can only appear a maximum of 3 times in this. The reason why? Because if it appears 4 times, then it means the total will be 32, which is higher than 30. So 8 can only appear a maximum of 3 times. So I'm going to write 3 8s on here. 1, 2, 3. So I have a guaranteed answer that 8 will be the highest. So, if 8 is now our highest possible number that we can get to, we still need our range of 6, which means the lowest possible number we can use is 2. So, because 8 take away 2 gets you, well, 6. So now we must fill in the gaps. Well, we need 2 numbers that make a total of 4. So let's figure it out. So we could do 3 and 1, but the problem is then 1 would be the lowest number, so we don't get a range of 6. Or we could do 2 and 2, but then we got another problem. It means that there'll be more than one mode then. So the problem is we have too many 8s. So let's rub out one of our 8s. Actually, I'm going to keep that one there. I'm going to rub this one out. And I'm going to choose a different number. I'm going to choose 5. So now I've got a total of 2, 7, 15, 23, meaning we need 2 more numbers, making a total of 7 to get to 30. So how about 3 and 4? Let's now try it now. 2 plus 3 is 5, add 4 is 9, add 5 is 14, add 8 is 22, add 8 is 30. When you divide by 6, you get a mean of 5. 8 take away 2 gets you a range of 6, and 8 still appears the most, so we have a mode of 8. The reason why I changed my mind is to show you that sometimes you might have to think a bit more outside the box and think of all the possible scenarios. You might have got a different answer to me, and it doesn't matter if you've got a different answer, as long as it meets these 3 conditions, that's absolutely fine. Now today we're going to be looking at a more complicated method of finding the spread of data. Now, when I told you there were 2 methods of finding the spread, I lied. There's actually 3. There's one known as the standard deviation, and there's one known as the interquartile range. We'll be looking at the interquartile range next week, because I'm going to be extending our statistics to next week, because there's a lot to cover. We're now going to be looking at the standard deviation, which is a very complicated one to follow. The only thing you need to help you with it is you need to know how to find our mean. Let's get into it. Now, to find our standard deviation, we first have to find the variance, which, well, clue in the title, it's how much our data can vary. Now, I've got a set of 6 numbers, 6, 5, 4, 2, 1, 9, and I want to find the variance. How do we do it? Well, as I was taught at school, to find the variance, you do the mean of the square minus the square of the mean. Now let me explain what that means. So this little symbol here is the Greek letter of sigma, which is actually what represents the standard deviation, so sigma squared. Now this bit here actually means the mean. That represents the sum of our data divided by n, which is the number that's used in it, all squared. And that is the sum of our data squared divided by n. So let me now show you what I mean because for all you know, I could be talking random gibberish right now. So it's better if I just show you. So the first thing we have to do to find the mean of the square is we have to add together all of these numbers, but these numbers all have to be squared. So instead of 6, it's 6 squared plus 5 squared plus 4 squared plus 2 squared plus 1 squared plus 9 squared. So we have to add all of those together. So let's do it. Well, you will need your calculator. 6 squared is 36, plus 5 squared is 25, plus 4 squared is 16, plus 2 squared is 4, plus 1 squared is 1, plus 9 squared is 81. That will get us a total of 163. So, we need to find the mean of that squared. So we have to divide 163 by how many numbers there are, which is 6. And that will get us 27.166666667. So what I'm going to do is I'm just going to put 163 over 6 here, because we know that is the mean of the squared. The next thing we have to do, which is the square of the mean, is we have to find, well, just the general mean. We don't have to square it. We don't have to like square these numbers. You just have to do what you normally do for finding the mean, except once you've done that, you square your answer. So we do 6, add 5, add 4, plus 2, plus 1, plus 9. That gets you 27. You divide it by 6, that gets you 9 over 2. And then what do? We have to square that answer. And when you square it, we get 81 over 4. So, what we did is we did the mean of the squared, which is 163 over 6, and the square of the mean, 81 over 4, and we have to subtract them from each other. So do 163 over 6, take away 81 over 4, and that will get us 83 over 12, which I will write up here. 83 over 12. Now we have calculated our variance. Absolutely fantastic. Now, do you remember when I said earlier that this represented a standard deviation squared? What do you think we have to then do to find our standard deviation? We have to root our answer. So remember to square root, you press this button on your calculator and you put the root 83 over 12, and that will get us to 2 decimal places, 2.63. And that is our standard deviation, upper SD, 2.63. Now the standard deviation represents how much our data deviates from the mean. Now remember, the mean is the strongest average. So if there's a large standard deviation, then there's a lot of variation and a lot of deviation from our mean. But if it's smaller, then it means that there's a lot more consistency in our results and our mean is more trustworthy. Now 2.63, now bear in mind our data is quite bunched in together. 2.63 is quite big. So I'm going to say that the mean isn't really that accurate, because look how far this all deviates from our actual mean, which we got down here. It's quite big. It's just another way of finding the spread, but like the mean, the standard deviation is the most accurate way of doing it. So remember, how you find the variance is you do the mean of the squared, subtract the square of the mean, and then to find the deviation, you just do that, and then root your answer to get this. Let's do another one. So here's your challenge. You guessed it, School A and School B, they're not giving up. They decided they're going to go for one final showdown. This time it's with English. They got 7 pupils and they did a spelling test, and they decided to see how good their results are and their new teaching methods. Now, because they chose 7 pupils, we got an N of 7. They got the sum of the square of their answers as 1,036 in A and 1,360 in B, and they got them sum of their normal answers in general as 84 in A and 96 in B. Which one has a more reliable teaching method, and which one would you go for? So, firstly, let's find the standard deviation of A. So we do the mean of the square, which is 1,036 divided by 7, which I'll write down here. 1,036 over 7 minus 84 over 7 squared. So that gets you 4. And then all you have to do is root that answer and you will get 2. So the standard deviation of school A is 2. Now let's find the standard deviation of school B. So we do 1,360 all divided by 7 minus 96 all divided by 7 squared. So let's enter this into our calculators. 1,360 divided by 7 minus 96 all divided by 7 squared. Then root that will get us to 2 decimal places, 2.49. So without needing the mean, without needing the standard, yes, I get it. B has a higher mean, but I would trust A's method more because the spread of the data, the standard deviation is lower, and so it's more trustworthy. There's a much more consistent feel with the results. Yes, B's only about 0.5 higher, but A is, well, lower. So, I'm not going to do a challenge for today because it's a Sunday, and tomorrow we're having a special one-off episode. We're not going to be doing statistics tomorrow. We're going to be doing statistics from Tuesday. Tomorrow is a special celebration because we would have reached our 100th episode. So I'll be doing a little special on that. I'm looking forward to doing it. And then we're back to statistics on Tuesday. Hope you've enjoyed statistics this week. I'm looking forward to carrying on with that. But let's bring on our 100th episode special tomorrow. Take care, guys. See you then.